All right, thanks. Yeah, thank you so much for having me. My name is Stefan. I'm the project lead of BirdNET, and with me is Josef, who is our leading maintainer of our open source repository. And I'm going to talk about like AI-powered bioacoustic monitoring. And I'm not sure how many people are familiar with bioacoustics and acoustic monitoring. So I'm briefly going to introduce why we are doing this. And as you probably all know, we're in a biodiversity crisis right now. And people, and this is actually from a scientific research paper, estimated that if we continue our path, we'll see a rapid decline in biodiversity over the next few decades. And so the things that we have to do, okay, we have to implement some changes to actually try to bend this curve of biodiversity. And we have to actually implement like lots and lots of changes to really get to like an increase in biodiversity over the next decades. And so the question that always arises is, okay, if we implement all these measures, how do we know if we're actually impacting biodiversity? How do we know if we're actually bending the curve? How do we track progress? And what I'm going to propose today is a tool that we call passive acoustic monitoring or acoustic monitoring in general. And I'm going to kind of briefly introduce some of the advantages that acoustic monitoring has as a tool to track biodiversity progress. And so the first advantage is that it's a non-intrusive method to monitor ecosystem dynamics. And it's non-intrusive because the only thing you typically do is you put out these recording units, strap them to a tree, and then just leave them there. So you only have to go there once. It has a very low disturbance to the species. You don't have to go there all the time and monitor. You just put them out there, and they typically last 3 to 6 months on a bunch of batteries. And then someone goes out again and collects all the data. You do have a continuous data collection, which is super important. You don't just have like these point counts, someone going out and monitoring for 5 minutes. They might miss a species that is there. You have a continuous recording, and it's all on record. And you can also like monitor in challenging terrains because again, you only have to go there once. Like someone has to go there once, has to go through the rainforest or has to climb a mountain, put the recording unit out, but after that, you just leave it out there. And then the second thing is, why birds? Why are birds so important for bioacoustic monitoring? And the answer is birds are indicators. Birds are indicators for ecosystem health. And the reason is they're very sensitive to environmental changes and they rapidly respond because they have annual breeding cycles. So the next year you will know if the measure that you implemented, you will see the success or like the failure of the measure next year in seeing like more breeding pairs or more breeding species. They're globally distributed. Birds are everywhere. They're culturally very important. Like everyone knows what birds are that they sing. Like everyone has a relationship with birds. So it's typically relatively easy to communicate to people why it is important to monitor birds. And then, most importantly, the vocal. And we're talking about like acoustics and birds, like they sing, they chirp, they make sounds, and that can easily be recorded. All right, so how does it look like if we try to implement changes and then track them with our system? So typically what happens first is you record sounds and then you store them in an archive. So you collect SD cards, put them on a hard drive, and then you can run our algorithm, which is called BirdNET, which is an AI power system, which I'm going to introduce in a few moments. You interpret the results, like you get detections of different birds, and you kind of like derive some conclusions from it, and then you make a decision. And the decision could be, is this forest going to be a national park? It's like this and that funding period. Are we going to extend it to protect the forest or whatever? Like you make a management decision. And after you made this decision, you're going to continuously record over large spatio-temporal scales, which you can because it's cheap. These recording units are cheap. And then record again, get the data again, process it again, and then track the progress. Because the year after, you will know if the measure that you implemented actually had an impact. All right, so we built BirdNET in a way that it can run on many different devices, which is important because it really takes like a distributed approach to do bioacoustic monitoring. We've seen these units that are passive. They just record, but they have SD cards in it, so you can process the data afterwards. There's an app that lets you record the bird sound and will tell you which bird it is. There's solar-powered units. There's units that you can buy and put out in your backyard. There's these drop-off recording units, and I'm going to introduce this one a bit more. And then there's these really large battery-powered deployments that can record 24/7 and they're autonomous. So there's a different bunch of recording units, and so they're all powered by BirdNET and eventually Python. All right, so first of all, the thing that I wanted to introduce is our BirdNET app, because if someone in here knows the BirdNET project, then it's probably through the app. We do have a smartphone app. It is free. You can download it for iOS and Android. And what it will do is it will allow you to record the sounds of your environment. We will visualize the sounds when you see a spectrogram so that you know what you recorded. If you see something interesting in the spectrogram, you select it, you hit submit, it will be sent to a server in Chemnitz that will run a CNN, BirdNET, and it will tell you which bird it is. And then you can click on the species and you can learn something. So for you, it is like the learning experience. You can learn something about the species you're recording. And for us, it is a data collection process. We get observations from, right now, 2 million people worldwide that are submitting data, and we collect that, and we can use that to do our studies. This is the map. BirdNet's been out. The BirdNet app has been out since 2018, and this is the map of 140 million observations that we collected, which is like an insane number if you think about it. It's just like this small university project, and it's a bunch of people working on it. You can see, obviously, there's a bias in there. There's people in Europe and in North America using it the most, but there's also people in India, Australia, Southeast Asia, South Africa, and even Brazil. And those are like the interesting areas because that's where the endangered species are. And so like we can see there's a lot of white spaces on the map. Like we have to like improve our coverage in Asia and in Africa, but that, yeah, we'll probably get there. But I think it's super impressive to see how many people are interested in birds. All right. The next thing I want to introduce, I mentioned that BirdNet is open source and that Josef is maintaining our open source repository. And I just want to like briefly introduce, hey, this is something we're not working on. It's not proprietary. We're not just keeping it for ourselves. We want to open source it because if we keep it proprietary, we're the bottleneck. And we don't want to be the bottleneck. We want people to use it and do bioacoustic monitoring and do biodiversity progress tracking. And so we built this repository. It has the newest and most recent model in there that covers roughly 6,000 bird species. In case you're wondering, there's roughly 10,000. The reason why there are a few of them missing is because there's not enough training data for all of them. It runs on all kinds of operating system. You can train, you can analyze. It has a GUI, which I'm going to introduce. It even has a server API, so you can host your own API if you wanted to. It has a metadata model, which will tell you which species occur at which time of the year. And we have a dedicated Windows built-in installer and a Python package, Raven integration, and so on and so forth. And it's pretty popular, which is surprising to us that so many people are using it. And there's some caveats that come with it that make it difficult to maintain, and I'm going to mention a few of them. I think when I was wondering about like the success, and this repository is made for biologists and ecologists, and the first thing we did is, okay, let's just put the model out there and add some tutorials on how to use the models. And then people asked, yeah, I want to use this in a command line. Can I have like a command line interface? Okay, let's build a command line interface. And then ecologists and biologists said, well, we don't want to use command line interfaces, right? Nobody does that. We don't want to know how to use it. We're not using it. We need a GUI. And we said, well, okay, this is getting complicated. How do we add a GUI to it? And we just decided to go like, yeah, take the easiest route. We do have a TensorFlow backend, so BirdNet is trained in TensorFlow, and the easiest thing for us to use for model deployment was Gradio to build a interface, and it has like pretty good like UI elements prefabricated. It's not super easy to use, but you can build like relatively complex interfaces that are tailor-made for deep learning models. You have audio input, you have image inputs, you have like drop-down menus and all these things, and you can just like align these elements. And then we use PyWebView to display the UI because it's web-based. Eventually, it can run on. It could be a website. You can run it. You can host. It even has an API. Gradio does let you host an API. But we decided, okay, let's use web technologies. That's probably going to be the easiest, the most compatible with most machines. All right, and then that was kind of like when things started to take off, because now biologists were using our software. It wasn't a command line tool anymore. They could just use a GUI, and there's like all kinds of projects. This is a map that we just recently built to keep track of like the projects, and you can see it has like worldwide distribution of where people are using BirdNET to monitor, like to actual monitoring of like certain species. And this one example, the Cape Parrot project, is like the Cape Parrot is an endangered species in South Africa, and there's a group dedicated to monitoring this particular species. And there's more. And you can also see it's not just birds, it's also other taxonomic groups. There's frogs, there's mammals, there's insects in there. And the reason is we allow people to retrain BirdNET based on the embeddings. The same embeddings that we just saw in the facial recognition demo, we use BirdNET to, like, if you have a sound, we use BirdNET to create the embedding. And then if you have a bunch of embeddings, you can actually say, hey, this is this species, put a label on it, and now you're able to recognize the species once it vocalizes it. And it doesn't even have to be a bird. All right. Since it's open source, and the beauty about like open sourcing stuff is that the community will eventually pick it up and build something that's amazing that you've never thought of. And one of these really, really cool projects is BirdWeather, which is a website that collects data from citizen scientists that maintain monitoring stations around the world. And if you look at the map, these are all citizen scientists maintaining backyard listening stations, which is, I think, even in Europe, that's like roughly 500 stations, and worldwide there's 1,000. And so like BirdWeather has a really nice API. You can add data to it. You can retrieve data from it, which is going to be like a super important tool for people to search for particular sounds and search for species. And this is a monitoring network of species coming and going. You can watch in real time species detections coming in, which is really cool. Then there's HiQBox, which is one of the devices that I mentioned earlier that you can buy and put out in your backyard. It's like, yeah, plug it in and there you go. It does monitor 24/7 for birds, and it has an app that comes with it that can access a web page that just shows you the detections, which is a learning experience for you and for us, or for the company that builds it, that we're collaborating with. It's a data collection tool. And so there's more and more people monitoring biodiversity in their backyards. What you can do if you have like a bunch of these data, you can actually do one of these animations. So it's not animated right now, but you can watch the video and just see like migrating birds coming in. You'll see more and more detections in the, well, the contrast is not nice, but this is the US. You can probably tell from the shape. This is the US, and you can see the species coming in, being detected of these recording units south, and then wandering off north, and then in fall they all come back, and you can see the detections, which is really cool. Another cool thing is, if you maintain such a listening station, you can learn something about your backyard. And this is an actual user story from one of the users who cut down an oak tree in their backyard and then was disappointed that all the birds are leaving. And you can actually quantify the effect of cutting down the oak tree. You can see the detections before, like the number of detections they had in their backyard. They cut the oak tree down, and now the detections go down. So this will tell you something about your backyard. What do you have to do to attract the birds? What do you have to do to provide like a space for biodiversity to come in? And that's, I guess, for a citizen science project, that's a really cool outcome. That's like you can actually teach people to contribute to biodiversity. And so there's the do-it-yourself version of it, and this is like really cool. This is not photos that we've taken. This is from the community. So every one of you, if you're interested in like maintaining, building your own backyard listening stations, you can go to birdnetpy.com, which is another community project. We have nothing to do with it, just advertising it. Copy it on a Raspberry Pi, put a cheap USB microphone in it, put it out in your backyard, and then upload the data to BirdWeather. And then just learn something about the bird species that are in your backyard. All right, so like overall, I think, and that's for us, that's like something that's super important to point out, is that open sourcing BirdNET has been extremely successful for us and has spawned like these great projects that we just saw that we could have never realized on our own. And I think it's safe to say that open sourcing in general, I guess, can be very impactful if you have the people power to maintain the community, to manage the community, to talk to people, to do support, which is actually a lot of work, but you can actually have like the outcome is just amazing if you get like all these really great projects from it. All right, back to passive acoustic monitoring and to like from citizen science to the hard science. Typically, I mentioned this, you put out these recording units, they're inexpensive, you can put out thousands of these across like vast landscapes, like in this case, the Sierra Nevada, and all these like each of these blue dots is a recording unit. So we're monitoring the entire Sierra Nevada. This is a huge monitoring project, and each breeding season, which is like, yeah, a few weeks, like typically these recording units run for a few weeks, that's 1 million hours of audio. And this is what 1 million hours of audio typically looks like. You end up with like a stack of hard drives, and then you have to process it, which is a bit cumbersome, and you need like a really efficient neural network to do it. You can't just use like a large, like maybe the best possible network. Like it has to be efficient too. So you have to sacrifice a few percentage points in accuracy in order to be able to process 1 million hours in like a reasonable time frame. But if you do that, you can do these large spatiotemporal analysis, and you can, for instance, look at fire disturbances. As you may know, the Sierra Nevada, like usually there's these huge fires every year, and then vast areas just burn down. And you can look at trends, like which birds are benefiting from fires, which are losing, which are on a decline. And so this will tell you something about biodiversity progress if you do this every year in the same area. And that's what I talked about. This is like one of these measures that we can implement using these tools, looking at these trends, understanding what these fires do, and then make a management decision that is meaningful to biodiversity. All right. If you do passive acoustic monitoring, you bring out these recording units, you wait for a few weeks, you come back with the data, and then you do the analysis. But there's some use cases where waiting for the data to be recorded, waiting for someone to bring the data is not good enough. Sometimes you want to know right away if a species is there. And I'm just going to give you an example while real-time acoustic monitoring can also be super useful. We have a small project with the Bavarian Forest National Park, which is, as you might know, one of the largest contiguous forest conservation areas in Central Europe, and it's roughly 1.3 million visitors per year. And if you look at this landscape, this is not necessarily a healthy forest. There's some degradation in there, which is mostly through wind and climate change, but also because of these guys down there, the bark beetle. And so this landscape is changing. And one species that is benefiting from this change is the Western capercaillie, which is a cryptic and easily disturbed species, and they need open habitats to breed. So they select these open forest areas to breed, and it's incredibly hard to predict where they're going to breed because there's more open habitats than there's capercaillies. And since these birds are so easily being disturbed, and you think about 1.3 million visitors, you need a way to know where they're going to breed to close off trails so that you can steer the visitors away from these birds. And so that's something where, you know, okay, I want to know right away if this bird is vocalizing, because if it's vocalizing, I know it has occupied a breeding ground, and I'm going to shield this breeding ground from the visitors. But then the question is, okay, real-time acoustic monitoring, how do you do that? How do you do real-time with these recording units? And we partnered with a company in Germany, which is called Öko4, and we built these solar-powered recording devices that have a Raspberry Pi in it. It's a Sleepy Pi on top, which does like the wake up. You can't record 24/7. You typically record like 5 minutes every 30 minutes. It has a Wi-Fi dongle in it, and it has some batteries, and on top it has a solar panel. And you can put these units out. You do this before the breeding starts, so it's like low disturbance. Then you let them sit there. They last for several years. They can just sit there. Since it's open breeding grounds, you have sunlight to charge the batteries. Typically, you only record during the day. That's fine. And then as soon as you detect a bird, you run the detection on device, and then you get the detection, you know where the birds are. And so this is how it works. The bird is vocalizing. It is being recorded when the recording unit is actually listening. We will run BirdNET on the device, so BirdNET is efficient enough to run on a Raspberry Pi. Data is being processed. You cut out these snippets that have the bird in them, and then you upload these snippets, and then they will go to a database, and then eventually you have a front end, which might look something like this, and there's a biologist sitting in front. This is an R-Shiny app, by the way. There's an ecologist or biologist sitting in front, and then verifying the detection. And oh, that was a capercaillie. I know this is where the recording unit is because they have a GPS location, and they can make a management decision. And so that's as soon as we show biologists that they can have the results in real time, they don't have to wait for 3 months. They want to have it in real time. And so that's like, it's super important to have these use cases in mind when training deep neural networks. It's not just about performance, it's about like deploying these things and being able to deploy it to these kind of like, yeah, scenarios and use cases. All right, but sometimes you can't just, like, the Raspberry Pi is a pretty powerful platform, but it's also power hungry. Like you've seen the battery pack that goes in there. You can't record 24/7, and sometimes even that is not good enough. And so we realized, okay, we have to probably move away from the Raspberry Pi, move to microcontrollers, and then we need something like BirdNET Tiny, because on these microcontrollers, you can really run only super tiny models. And so the challenge is going from like BirdNET, which uses a 3-second audio snippet sampled at 48 kilohertz, which has eventually as a spectrogram 96 times 512 pixels. And by the way, spectrograms, we've seen this, are like visual representations of the audio. So we're actually doing image processing and not audio. Like it's a CNN that we're using. We're using spectrograms. So we're converting audio to spectrograms and input an image and then look for pattern. BirdNET has roughly 10 million parameters. So it's pretty small already and roughly 30 megabytes in size. And now we're going to 1.5-second signals sampled at a lower sample rate, only 40 by 43 pixel spectrograms, and less than 10,000 parameters, and less than half a megabyte in size to fit on these tiny microcontrollers that are super power efficient. So like thinking about like billions and billions of parameters in these large language models, we're talking about less than 10,000 parameters. All right, and this is our target platform. This is the puck that I showed you earlier. They had a pretty successful Kickstarter campaign, but inside is a pretty sophisticated custom board that has an ESP32 microcontroller on it. It has 2 microphones. It has a GPS module. It has a real-time clock, and some other additional environmental sensors. It's roughly the size of your hand, and you can go online and buy it. And it's like a pretty cool hybrid between like a 24/7 listening station, cloud deployment that processes 1 million hours. So it sits somewhere in between. And there's a few different use cases that we had in mind when designing this device. The first one is drop-off monitoring. If you're a ranger in national park, you grab a bunch of these, go out, put them there, let them listen for a day, bring them back in, and then you have a companion app and you can connect to through Bluetooth and you see the detections. It's all been done on the device or partially device, partially the companion app, and you instantly know what's there. You instantly know what's going on in your national park or like the forest that you're maintaining. You could think about bioblitzes, and again, this is citizen science. You can these things are relatively inexpensive. They're going to be cheaper the more they produce. You can handle. You can think about giving this to school children and say, hey, over the weekend, these things last 72 hours roughly on batteries. Give it to school children, put it out in your backyard. We meet on Monday and then talk about these things that you've recorded, and then learn something about the stuff that was in your backyard, and then try to reason if it's the correct detection. Why do we have so many of these birds in this backyard and not the others? You can easily see that there's going to be value, educational value in these things. And then another thing is we thought of was backpack monitoring. You can strap this thing to your backpack and walk through a national park. You can even say, hey, targeting ecotourists, we don't have enough rangers to monitor the birds in our national park. If you go out, if you go out camping, if you go out hiking, please take one of these, make a few recordings, bring them back, put them into a docking station, and now as the National Park Service, we know what you've recorded. And so this is kind of this hybrid hard science, citizen science, which is probably a really cool use case. All right, a few closing remarks, and some future works, and basically our vision, and it's going to be this slide again. I mentioned all these different approaches, these different tools, different services, different devices, different models and all. And I think it's really important to emphasize that one person or one institution alone cannot bend the curve. It takes a collaborative effort to actually do it. And so we have to make sure that we build interfaces, that we build frameworks, packages, software tools, devices that anyone can use, because we have to bend the curve together. All right, if you're interested in our tools, especially the tool for the hard sciences, you can go to birdnet.cornell.edu/analyzer, or ask us afterwards. We're probably going to be here for a few beers. Thanks.
Stefan. Let's switch just to the slides. Yeah, to this one.
Sure.
So again, we have the same Slido PyPRG17 as before. Feel free to ask questions, upvote existing questions, and let's have a we'll have a look. So, how do you deal with possible dataset poisoning? Do you implement any precaution measures?
So the difference, like the data sets that we saw before are just crawled from the internet. The data sets that we use typically have handpicked data. There's these large collections where citizen scientists upload their recordings and they label the recordings. So we do know, like we have like a pretty good understanding what's in these recordings. We handpick a few of others. Like just to mention the size, like BirdNET uses roughly 10 million samples to train. And so that, which is far from like the amounts that we've seen before, and it's still possible to curate these data sets. There is, of course, label noise, which is tricky sometimes because even like with 10 billion samples, you can't look at all of them. And sometimes it will just like introduce some sounds that are not the bird. And to some extent, label noise is okay, but sometimes it'll just like break things. And we just realized that some species in BirdNet actually do have a lot of label noise. Up to 50% of the samples are noisy or not the bird. And so we actually have to figure out a way how to curate these data a bit better. So yes, poisoning yeah, I wouldn't call it poisoning. It's noisy. It's noisy to some extent, but we do use curated data sets. We do have the permission to use these data sets. We ask people, we collaborate with a lot of people, and they contribute data. And so we know what our sources are.
Okay, thank you. Another question, isn't analyzing spectrograms of sound less efficient than analyzing the sound itself?
Yeah, you would think so, because sound is like a time series, right? And you would think, hey, well, you know, like the sound that I just heard has an impact on what I'm going to hear next. And if a bird vocalizes it, like it has a certain sequence of notes. And so we tried a few things, and people have tried like yeah, recurrent neural networks and all these things, and it didn't really work out. Like CNNs were always beating any recurrent approaches, and even transformers are outperformed by CNNs. And I guess the reason is that 10 million samples is just not enough to train a transformer. And so we're probably going to shift to self-supervised learning. We do have 140 million recordings from app users, so that's a good data set to do unsupervised learning on it. And so we're probably going to move away from CNNs and hopefully like make actual use of the time series, time series data that audio actually is.
Okay, thank you. And how do you work with data quality? Like the cheap recording devices must be unreliable. How do you deal with that?
Well, there is some diversity in there, but I always say that diversity beats quantity. If you have a super nice microphone, like typically these birders go out with a parabolic dish, they point it at the bird. There's a really like super expensive microphone in there, and you get a really high quality recording. But that's not what reality is going to sound like. If you're going to deploy a recording unit that has like these omnidirectional cheap, like I don't know, 10 euro microphones in it, that's going to sound completely different. So you need these noisy or like bad quality recordings in your data set to kind of make your model more robust. So like these sources are super important, and I think people usually get fooled by the quality of these phones. Like these phones make super high quality recordings. It is amazing. You listen to them sometimes and you just, that was a phone? I can't believe it. It's incredible. Like it's not like there aren't too many super cheap devices out there. So it's surprising what you can get out of these phones.
Okay, cool. Another question is, what is the architecture of BirdNet? You already touched it, but
Yeah.
could you please
So we since we're using spectrograms, and typically CNNs use square inputs, which is for a spectrogram, it's not ideal because typically you have a higher resolution in the time domain. So they're non-square inputs. You could like squeeze them and put them in there, but that's not. So we decided to use a custom architecture to deal with that. And spectrograms are only one channel images, and then typically these off-the-shelf networks use 3-channel RGB inputs. And so we figured, okay, let's use a custom architecture. But it was cumbersome to explain to people what the architecture looks like. So we just like moved away and just used efficient nets.
Okay.
So.
Thanks. Another question is, are the names of identified bird species by the mobile application available only in English or also in local language?
Well, we do have I think we do even have like a Czech translation for the species names and the interface, which was a community effort. Like people approach us, say, hey, I want to contribute to the app. I can translate the app. We know that it's like super important to have these local names of species. I'm not sure. I think we have 25 languages for species and 14 or so for the interface. But we can't do it. Like someone else has to do it. And so like we're asking the community to contribute these languages. But
By
yeah.
the way, as a first-hand user of the app, I can confirm that the Czech names are available, and also there are links to Wikipedia.
Yeah.
So articles describing the species. If you would you have a link how to contribute? I think it would be worth of sharing.
Yeah, you can just like go to birdnet.cornell.edu, or if you open the app, I think it has in the app it has like an about us page, and then one of the first sentences is like, hey, if you want to contribute, this is the email address, and it has like an email address that you can just send it, and then there's Ashik, our community manager, will eventually see the email and forward it. It might take a while because we're just getting so many emails.
There's another concern about contribution. How do you do the data labeling? Is there any approach for filtering out personal data from 24/7 recordings that could happen unintentionally, like the backyard?
Yeah, so what I mentioned, like this school children example, what you don't want them to do is put this device into their sister's bedroom and just, trying to record what she's doing. So you need to raise the awareness. Like you have to talk to people first and make them aware that you can't just put a recording device anywhere. But what we did is in BirdNet, there's a human recognition in there. Like you can detect human speech, not what is being said, but just that someone is talking. And when these recording units detect a human, they will stop recording. They will not submit these recordings, and then they will continue. The BirdNet app has this feature. So the BirdNet app is a bit different because you have to submit first and then know what's in there. So it will tell you that it detected a human, and we would just get rid of these recordings and not use them for our research because there's probably not even a bird in there.
Cool. The next question is, how does BirdNet compare to Merlin, or is it the same thing? There was Cornell mentioned somewhere in the slides.
Yeah, so Merlin is an effort by the Cornell Lab of Ornithology and Macaulay Library, which is one of these large community collections of sounds. And so they're just across the hall, like this. On the one side of the hall, there's the bioacoustics group, and on the other side of the hall, there's Macaulay Library. And Grant Van Horn, who developed the Sound-ID feature, was one of the close collaborators of ours. And we had bi-weekly meetings. We talked about the technology, and there's a lot of the ideas that went into BirdNet also went into Merlin. The difference is they used their own pipeline because the BirdNet app was never intended to be a real product. It was intended to be like a proof of concept. And so, but they wanted to build like an actual product. And so they have this production pipeline, which is actually super sophisticated. So they know which bird they're not doing a good job on. They have an interface where you can label data. They ask expert, hey, this bird's not doing well. Can you label a few more files? They label it, and once per week, they will fire up their retraining pipeline, retrain the model, and then deploy it, which is actually super sophisticated, which is, it's too much engineering for us because we're focused on the research. And again, BirdNet, like the app at least, was never intended to have 2 million users. That was not the plan.
So there's another question. If it is possible to recognize a single particular bird, just like humans have a distinct voice, so you know that a particular bird returned.
So we know that birds can do it. We know that from playback experiments that if you play back a territorial neighbor, the bird in this territory will respond more aggressively. So birds can recognize like individuals. So you would think, okay, somewhere within the song, the individual identity has to be encoded. Like it has to be there. And typically how you would approach it is through embeddings. You would take the sound of this one individual, get like the fingerprint or the embedding from it, and then create the identity and then try to match it. I think it really depends on the species. For some species, it's easier to identify the individual. For others, it's a bit more complicated. People are doing work on exactly these things. I'm not exactly sure if the embeddings that BirdNET produces are good enough to do individual recognition because these differences have to be very subtle. But yeah, people are working on it. I can't do it. I'm not an ornithologist, so we don't have the data to do it, to quantify these effects, but other people do, and so. Yeah, it might, yeah. So that might be, like we are looking at 3-second snippets, and for some species, you look at the call pattern and the pauses between these calls, like to get like the fingerprint, and so that's something that you can't do eventually, hopefully, when moving to transformers, again, there's this time series characteristic of audio, so maybe then it'll be easier to do that.
Another question is easy. How can I contribute to the measuring? What are the options? What is the easiest one? If you could summarize the.
Well, there's these. Well, you can use the app, of course, as a starter. But I guess the app has some biases, and because typically with the app, people only record birds that are singing, and they only record the birds that they don't know what they are. So there's this bias. But sometimes it's also interesting to know what's not singing. You want to know which birds are not there. And so that's, I think, only possible with these 24/7 monitoring stations, because then you get like a relatively good overview of what's there and what's not. There's, of course, still some biases. People in urban areas will use it more frequently. People in the Western Hemisphere will use it more frequently. But I guess like the best way to contribute data is like go to birdnetpy.com, hook up your Raspberry Pi, program it, put a microphone to it, and put it out in your backyard, and add it to the monitoring network.
Cool. Next question. There was a small device at the end. Displayed in the presentation, is there an open source version of it?
No, not yet, I think. Because it's a custom board. I mean, what we're doing with BirdNET Tiny, this is also going to be open source. And since there's an ESP32 in it, which is a common microcontroller, I think one of them costs like 12 euros or something. It's relatively inexpensive. We will make sure that if you have one of these controllers, you can run it. You can, solder your own microphone to it and then build your own device. So we're not going to keep it proprietary. In this case, since it's like a real actual product that has to be produced, it has a proprietary board in it. I'm not sure if they're going to open source it, but at least the model is going to be open source at some point.
There's another question. Do you correlate the bird tracking with satellite or other soil terrain analysis and other indicators of eco quality, environment quality, weather maps, mining, foresting?
We do to some extent. The app does. It uses other citizen scientist observations to kind of approximate which birds might or might not occur at a given time. Right now here in Prague, if you go out and listen, there's not much going on. And so like there's no way that some of these migrating birds are here right now, so you won't be able to detect them because BirdNet knows, hey, it's generated, that's not possible. Right now for like these larger ecological studies, we're just using acoustics. But we're really thinking about like integrated approaches of like using satellite data to assess ecosystem health. Biodiversity is not just bioacoustics, so there's more to biodiversity, and biodiversity is not just birds, even though birds are good indicators. So like it really needs like this integrated approach. Bioacoustics is one way to like measure progress, like one metric to assess biodiversity, but of course there's more, and we're really thinking about it. But it's tricky. Like it's tricky. How do you combine different data sources, which is never easy.
So we have room for, let's say, last one or two questions.
Sure. Yeah.
So what do you do with species that mimic other species?
Yeah, that's tricky. We know for a fact that the mockingbird actually works pretty well. The BirdNet can reliably detect the mockingbird, which is surprising because it's one of the best mimics. But BirdNet doesn't do a good job for starlings. Because that's like the most common mimic in Europe. And they imitate raptors or other birds hovering. It's super tricky. The mockingbird at one point will give it away. They will imitate a species, and then 2 seconds later the next one, and then the next one, and then the next one. So eventually you know, oh, there's something off here. But the starlings, they're just like doing a super good job. And then there's lyrebirds. It's challenging. I don't know if it's going to be possible at some point, but there's such good mimics. Sometimes it's super hard even for ecologists to distinguish the sounds, and so.
Cool. And the last question: do BirdNet outputs have any impact on landscape development decisions?
Yeah, that's our vision. That's what we want to have. It's like with the Sierra, these fire management decisions that are being made. Should we do fire prevention? Should we go out the forest and then just remove all different plants and whatever, like catch fire, or should we just like let it burn because it's good for some species? And so there's hopefully going to be landscape scale decisions. There's pretty much every national park in Germany is collaborating. The large national parks in the US are collaborating, and eventually as people realize, oh, we can actually use this tool, it's okay, it's reliable enough to do our studies, yeah, there will definitely be, and hopefully that's a vision, landscape scale management decisions based on BirdNET.
Thank you, Stefan.
All right,
So
thanks.
that's all. Stefan will be also around. Feel free to ask him
Sure.
questions in person. And let's give Stefan one more applause.
All right, thanks.